Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Azizi. Today I'm going to present my final year project, which is detection and classification on drone movement using LTE frequency and passive radar. As for the introduction, there are two types of radar, which are monostatic radar and bistatic radar. Monostatic radar is where the transmitter and the receiver are located in the same place. As for the bistatic radar, the transmitter and the receiver are located at different places. Next, forward scattered radar is one of the methods of bistatic radar. It used for the same concept as bistatic radar, but include 180-degree bistatic angle. As for my project, which is passive forward scattered radar, I use LTE tower as transmitter and passive radar as receiver. In my experiment, passive forward scattered radar is used to detect the drone movement when passing transmitter and the receiver. For the demo handy was used in this experiment to measure the signal strength, which are reference signal power resist RSRP and reference signal resist quality RSRQ. The table shows the condition of LTE strength, which are excellent, good, moderate, or poor. For the problem statement, there are a lot of criminal activity using the drone, such as smuggling, drug, or bullion. Next, the drone was used in prohibited drone areas such as government facilities. And as for the objective, first is to detect the drone droplet signature of the drone when the drone flies vertically and horizontally using LTE frequency and passive forward scattered radar. Second is to classify the movement of drone flies vertically and horizontally. Next, as for the methodology, there are three locations for the experiment. First is Kampung Bangkok. The second location is Maet, Serdang, and the third location is Batu Laut. As for the first location, Kampung Bangkok, the distance between transmitter and receiver is 128.33 meters. On top of that, Kampung Bangkok is rural area, and this makes the user of telco is the lowest compared to the other location. One location is Maes. The distance between transmitter and receiver is 146.60 meters. The Maes is a urban area, and that means there will be a lot of LTE tower communication surrounding. The final location for the experiment is Batu Laut, and the distance between transmitter and the receiver is 157.7 meters. This is the farthest distance between transmitter and receiver for this experiment. For the second methodology, I will explain about the drone movement detection. So, when the drone is crossing the baseline between the transmitter and passive radar receiver, there is a Doppler signature appear in MATLAB software. Is for the movement of the drone. First, the drone will fly vertically, which is upwards and downwards in front of the passive radar receiver crossing the baseline. Next is the drone will fly horizontally, which is fly right to left and left to right. The passive radar receiver must be placed towards the transmitter. As for the data processing, first the signal detection PFSR and the PFSR signal selection are the number of samples that obtained from three different frequencies at three different locations. Next, the The denoising process is to remove the unwanted signal that appear in the time domain. Next, power spectrum density (PSD) is the process of conversion from time domain into frequency domain. And lastly, classification is the process of the data of UD and RL is classified into their own cluster by using principal component analysis (PCA). The NEMO handy is used to measure signal strength. Data recording and data selection are the number of samples which are RSRP and RSRQ. Next is data extraction and the plot graph. And lastly is the classification of the NEMO handy. And this is for the result and discussion. For the first result at Kampung Bangkok, the time domain, it shows that the time taken for RL right to left is longer than UD up and down. This is due to the cross-sectional area of the drone radar are larger for RL while they are passing through the antenna receiver compared to the UD. Next, for the PSD, it shows that the RL has the lowest Doppler frequency than UD Doppler frequency because the time taken is high. The frequency will be lower. And lastly, for the classification using PCA, it shows that three frequencies at Campo Bangko achieve total classification of 100% since all clusters do not overlap with each other. This is due to the distance of antenna receiver and TV tower communication at Campo Bangko is the shortest. Next location is Maes. For the time domain, it also shows the same result, which is the time taken for RL is longer than UD. And this also for the same reason, which is due to the cross-sectional areas. As for the PSD, it shows that as for the PSD, it shows that RL has the lowest Doppler frequency than UD Doppler frequency because where the time taken is high, the frequency will be lower. And as for the classification, the 1.8 GHz and 2.6 GHz achieve total classification of 100%, while 2.1 GHz only achieve 96.6% due to 1.1 GHz lack of telco provider, and this can be proved in demo handy. And for the last location is Batu Laut. For the time domain, it also show the same result, which is the time taken for RL is longer than UD. Next is for the PSD, it show also the same result, which is the Doppler frequency of RL is lower than the Doppler frequency of UD. As for the classification, the The total classification of Batu Laut at frequency 1.8 GHz and 2.1 GHz is 100% and 2.6 GHz only achieve 95.53%. This is due to the weaker signal strength and also this is due to the many telcos provided in a bandwidth 2.6 GHz. As for the Nemo Handy classification, it shows that the Kampung Bangko has the strongest signal strength compared to other two locations, since signal strength shown in Kampung Bangko in excellent and good condition. As a conclusion, the passive forward scattering radar (PFSR) system can detect the Doppler signature of the drone movement. The Doppler signature of RL and UD show a difference in a time domain. And lastly, the movement of drones can classify successfully into their own cluster by using principal component analysis (PCA). That's all from me. Thank you.